Hello everyone, and welcome to another video about Godot. A couple of weeks ago, an issue was raised around the vehicle physics implementation in Godot 3.0. I decided to port the Trucktown demo to Godot 3 to try this out, and while it works, it is outdated and indeed showed some problems. To get a better understanding, I've been working on a new demo, an early preview of which is playing in the background. While the demo is far from ready, I thought it would be a good idea to make a short tutorial on setting up a car simulation in Godot. There are a few issues left, hopefully these will be resolved in the not too distant future. First, let's look at a few resources that we can use. HDR Heaven is a great site that provides free HDRI textures that we can use for our sky. Textures.com is another great site where we can source a few textures we will need. Next we have the Chronos GLTF exporter for Blender. GLTF is a new data format for 3D files. While new and still needing some tweaks, I have found that the export and import process work quite well. Note the instructions within the script subfolder that you need to follow to install this plugin in Blender. The car we'll be using I've obtained from TurboSquid, another great site where you can download both free and paid meshes of generally high quality. Finally, I want to give a shout out to Clelio Rossi. While I'm not using any of his assets in this tutorial, he provided the great racetrack you saw in the intro video. I have already created the project in Godot, and inside of this I have created an assets folder. Within this folder there is already a textures folder that contain a few textures that we will use. We are going to edit the default environment and change our background to use a panoramic sky map. We can assign the texture we downloaded from HDRI Heaven here. By setting this up in our default environment, we will have this map as the default in any scene we edit. For now, we are going to create a very simple scene. We will just create a floor that interacts with our physics engine. For this, we first create a static body. We add a collider shape to this with a plane as a collider. And we add a mesh instance with a plane mesh. We'll make this plane mesh nice and large, subdivide it a little, and apply a texture so we can actually see the ground move as our car drives over this surface. We'll rename a few things. I'm also adding a directional light to simulate the sun. While our scene is lit indirectly through our sky, this allows us to cast a proper shadow on the ground. To make this look nice, I attempt to align the light with the sun in our image, and finally turn shadows on. Here I'm adding a placeholder node for our car. We'll do this differently in a future video, but for now this will do. We also need to add a camera to our scene. The placement of our camera doesn't matter much right now. We will move it a little backwards. We will do more with the camera later on. And finally we save our scene and quickly test if it all works. Before we open up Blender, we'll add a folder to place our car files in. In our assets folder, we first create a folder called cars and then a folder called Caterham. We clear out Blender's default cube and camera. We leave the light so our scene is lit. Then we import our car into our scene. I have downloaded the FBX version of the car. That gave me the best results on import. Note that most of the materials have not come across. The car looks pretty bland at the moment. We will correct that once the car has been successfully imported into Godot, because we have access to the PBR settings there. There is one problem with our mesh that we need to fix before we can export it to Godot. Note that all 4 wheels are part of the same object. We will need to split them apart. I am going to hide all the other objects to make my life easier. After selecting the wheels object, we press Tab to go to edit mode. Press A to deselect all vertices. Now we can use B to select all the vertices that belong to one of the wheels. Blender has only selected the visible vertices and not the ones hidden at the back. Use this little icon in the toolbar to make Blender select hidden vertices as well, and try again. We can now use P to move this wheel into its own object. Let's fast forward, repeating this for 2 more wheels. This will leave the last wheel as part of our original object. Then press Tab to exit edit mode. Next, let's rename all our wheels so we can tell them apart. Now that all the wheels are split into their own objects, we notice a new problem. Each wheel still has their origin point set to the original origin position. We need to center the origin point of each wheel to the center of each wheel. To do this, we select a wheel, press Tab to go into edit mode, and select a vertex at the center of the wheel. Press Shift S to move the 3D cursor to the position of the selected vertex. Now press Tab to exit edit mode and press Shift Ctrl Alt C to move our origin point to our 3D cursor. If we had more time, we could probably find a better vertex to use or tweak our new origin point afterwards, but this will do for now. We need to repeat this for our other 3 wheels. As this is more of the same, I'll fast forward through that process as well. At the end of this, we can unhide all our other objects. Just in case we need to do more changes later on, we'll save our project as a blend file. Now we are ready to export our Caterham as a GLTF file, which we will save in the Assets folder of our Godot project. Now it's time to return to Godot. In Godot, we can see that Godot immediately starts processing our GLTF file. In the background, it converts the GLTF file to a format Godot can handle, and it creates material files for each material in our GLTF file. I did have to manually copy a number of textures that didn't come across automatically, and for some reason I ended up with both a JPEG and PNG version of the Speedo. Let's take a look at our GLTF file by double-clicking on it and choosing New Inherited. When we examine the scene that Godot imported a little closer, we notice that we suddenly have vehicle wheel nodes added to our scene. Now remember that when we were in Blender, we had to split the wheels out into separate objects and adjust their origin points. This is definitely not something we've set up in Blender. Either the GLTF export or GLTF import latches onto something and decides to add these physics nodes to our scene. If anyone knows what triggers this, please let me know in the comments. Now, I think this is a very cool feature. If this didn't happen, we would have had to save our wheels into separate files and build the scene tree ourselves. We do, however, see that there are some problems. Note the yellow triangles in the scene tree that indicate something is not correctly set up. When we look at the message Godot gives us, it tells us that the vehicle wheel nodes must be child nodes of a vehicle body, but the root node of our scene is a spatial. This is easily corrected by selecting our GLTF file and going to the Import tab. On this tab, we can change the type of node the import will use for its root node, and we can set this to vehicle body. I'll also change the name of the tab. After this, we can simply press Re-import to apply our changes to the scene being imported. While our scene's root node has indeed changed, the name hasn't, but that is easily rectified by closing and reopening the GLTF file. If we wanted, we could use the GLTF file directly in our project. I'm using the inherit function, however, because this allows us to make changes to the scene, and Godot will save these changes as overrides. If I would go back to Blender and make changes to my models and export these changes, Godot will re-import the GLTF file and attempt to keep as many of my changes as possible intact. We're going to make our first of such changes. We can see there is still a triangle warning us of a problem, and that is that our car does not have a collision shape. We could select the body of our car and use the create convex static body function to do this. Instead, I am going to create a very simple collision shape for our car. Just a box that roughly contains the main body of our Caterham. I'm keeping the shape conservative for now, because if our collision shape hits the ground when our suspension is not yet set up correctly, Newton's third law could send our car flying. I'll probably change this to a better fitting shape at some point in the future. I'm also quickly turning off our lamp. We should have deleted this in Blender. One quick thing of note is looking at the origin point of our vehicle body. Note that this is on the ground, and we got lucky that the import resulted in this. This point will act as the center of gravity of our car, and we want this to be nice and low. A higher center of gravity would lead the car to easily topple over. As we are about to work on bigger changes, this would be a good time to save our scene. We are going to start working on our material changes, and here the mantra "save often" really goes. It is interesting to note, as I look around our car, only materials used on the dials have retained their texture. I think this is because the other textures are used as depth maps, and that doesn't come across. I did have some problems using them as depth maps in Godot, so you will not see me doing that in this video, but I may revisit this in the future. The other mystery is that while the materials have lost their properties somewhere at the start of our pipeline, the preview images of our materials are correct. The GLTF import will create material files as it encounters new materials, but it will not overwrite existing ones. We can safely tweak the material settings without fearing they will be overwritten when the GLTF is re-imported. Not all the materials have a very useful name. We will have to go through them one by one, figure out what they are for, and adjust them. I won't talk about every material in this video. It took me nearly 30 minutes to set them all up, but I'll pick out a few highlights. Looking at our very first material, a handy way I find to figure out what it is used for is by simply changing the albedo color. We immediately see the outer wall of our tire turn red. A simple Ctrl-Z will undo our color change. Our tire right now looks like plastic, but this is easily changed by going to the roughness settings and turning up the roughness of our material. This should be a value between 0, not rough at all, and 1.0, which is matte. One thing that is really important making these changes is to always save with the button in the resource editor. If you do not save these materials, the changes will revert the next time you open the scene. The next material is called disk material, but it isn't actually the brake disc. It is the material used for the rim of the wheels. This is a material that we want to make really metallic so that it reflects its surroundings. Here we change the metallic property in the metallic settings, which works similarly to our roughness setting. A setting of 0 means not metallic at all. A value of 1.0 makes a very reflective material. I really like these PBR settings. As I was changing the material used for the exhaust pipe, I noticed that you could see through the inside of the pipe. While you have to be careful with this setting as it can be wasteful, I am simply turning off culling on this material. Now we can see the inside of our pipe. For our headlights, I'm first updating a material found a little further in our list, and that is the headlight glass material. This is supposed to be a transparent material, but for this to work, we first need to turn on transparency, and then change the alpha on our albedo color. After this has been changed, we can update the material that is used for the inside of our light. This is a material that needs a strong metallic setting. Now for the material I was really looking forward to doing, and that is our main body color. Here we simply change the albedo color to a nice dark blue, and then set the metallic setting to something nice and shiny. The end result, I feel, is fairly spectacular, especially with the HDRI sky. Another material of note is this material used with a carbon fiber texture. The texture was lost, so we need to reinstate it, but if you look at the source renderings, you see that the texture looks too big. We scale up our UV on this material to correct this, and tweak a few of the other settings for effect. The glass material used for the windscreen was imported without its transparency. For this material, we again need to turn on transparency and set the alpha on our albedo color. I like to give glass a hint of green for effect. All our materials are now set up, but there are still a few other changes we need to do. For some reason, the import process has applied a scale to our vehicle wheel. This scale should be applied to the mesh of our wheel. I'm guessing this is an error in the import, but it is easily rectified by setting the scale on our vehicle wheel to 1 and copying the scale into our wheel meshes. We need to do this for all 4 tires. This also allows us to correct the radius of our wheel, so that our physics engine knows the correct size of our wheel. In order for us to drive our car, we need to add some logic. Godot takes care of the bulk of everything, but there are still a few things that we need to do ourselves. I've prepared the code for this beforehand, so we are going to simply attach this script to our vehicle node. We'll be extending this script in future videos, but what is important is that the script was written to be used with different car models. We attach the script to our vehicle body root node in our car scene. Let's have a look at the code itself. I'm starting a few lines down where you see that I'm setting up some controller mappings. I've added some code in my physics process that reads out the axes related to these controllers, and if needed overrides these values based on the user using the keyboard for input. Odino has submitted a nice PR that would make it much easier to set up these types of mappings, but we're doing it ourselves here for now. At the top of the script, we define a number of export variables that control the acceleration, braking, and steering behavior of the car. These will be different for different cars, so this allows us to set these up. We also have 2 variables that we use to smooth out our steering input. Further down our script, we can see how we apply these values. Our engine force and brake value are directly determined by multiplying our controller input with our maximum values. In the intro at the start of this video, you could see that I have expanded on that greatly with support for shifting through gears, but we'll leave that for another video. There is a little bit more code for steering. We start by calculating a target value based on our controller input and then update our actual steering angle based on our maximum move speed. Here we can see on our car node that we can set our export variables to tweak them specifically for this car. Let's go back to our main scene and load in our car scene so it becomes part of our game. I have also prepared a very simple script to animate our camera, so let's load that in as our camera script. This script has our camera follow an object that you can set using the follow this path variable. It has a variable that determines how far away the camera should be and a variable that determines how high the camera must be above the object it is following. The code then simply smooths out that information to make the camera follow our car. Now we need to select our camera node so we can set our follow this path to point to our car. We must make sure that we set this to our vehicle body, not to our container node. One last tiny thing I want to do before we give this our first test run is to rotate the starting position of our car. When we run our demo so far, we immediately notice that our car has sunk into the ground. This is because with the default physics settings, our springs are not strong enough to hold the weight of the car, and it is now resting on our collision body. As you can see, everything does work. We can drive our car around just fine. This is mostly because our test environment is just a flat plane. Our car would get stuck very quickly within a real environment. For the last part of this video, let's have a look at the actual settings in the physics engine. We won't get our car set up perfectly today, in part because of some of the small issues that need to be resolved, I will, however, try to do my best in explaining what all the relevant settings should be. I will be showing these for one wheel only and copying the settings to the other wheels. That is always a good starting point. For a real car setup, you will often set the rear wheels up slightly different from the front wheels. On the vehicle body itself, there is only one setting that is relevant for us, and that is the weight. There are two settings here, weight and mass, but they are linked to each other. The weight is in kilograms, and looking up the specs for our Caterham, I found a value of 575 kilograms, which we will use here. One thing I realize now that I glossed over in my video so far is the first two settings on our vehicle wheels that I had already set up after importing the car. The first is use as traction, which needs to be on for our rear wheels, as this is a rear-wheel drive car. The second is use as steering, which needs to be on for our front wheels, as we steer with those. The first setting to talk about is the setting called Roll Influence. This setting is a bit of an odd duckling, as it is the only setting that is a bit of a cheat. A car will always have a limited amount of body roll as you corner. This setting is used to determine how much a car will roll. A low setting like this will result in very little body roll. A high setting will likely result in a car prone to flip over. We've already talked about radius, so let's look at the rest length. Now, rest length is an important setting which determines the distance between the center of the wheel and the top of the spring when the car is standing still. You can actually see the spring drawn into our interface and visually change when we alter this setting. There is one thing that is incorrect here, however, and that is that the spring is drawn upwards, while in reality our origin point actually represents the mounting point of our spring, and it is the tire that gets pushed down. We'll have to move our origin point upwards to compensate for this. For our tiny Caterham, this rest length is a little higher than it should be, so we are going to change it to 7 centimeters. Friction slip is a really cool setting that determines the point at which a tire loses traction. The higher this number, the less likely your tire will lose traction. Use a very low number, and it is like your car is driving on ice. You can use fun tricks like setting the friction of the rear tires lower than the front tires to create a car that easily oversteers. You can also simulate tire wear by slowly decreasing this value for a tire that is getting worn out. The default setting of 10.5 gives us a very grippy tire, which is fine for now. Travel is another very important setting. While rest length determines the length of our spring when the car is in rest, travel specifies the distance by which the spring will compress or decompress. The total travel is thus twice this number. This value is again in meters, so our default value of 5 meters does not seem to make sense. I think this is just caused by some confusion because the original value in bullet was indeed measured in centimeters, and internally Godot converts our value to centimeters. It should never be higher than the rest length. In our case, we're making it equal. The stiffness setting determines how stiff our spring is. I'm not sure what the units are, but basically the lower this number, the more bouncy the car gets. The higher, the more rigid the suspension gets. A value of 5 is definitely too low and will result in a car just bouncing around. You would use a value between 30 and 50 for cars that need to go off-road. A value between 50 and 100 would be good for a race car, while a value nearer to 200 is Formula 1 territory and will only work well on the very flat road surfaces. We will use a value of 70 for our car. The max force setting limits the amount of force our suspension can absorb. If you put this value too low, the spring will not be able to hold the weight of the car and it will bottom out. If you put this value to a quarter of the weight of the car, the suspension will be just about strong enough to hold the car up, but the suspension will fail at the first bump in the road. A value of 6,000 seems on the high side for our Caterham, but I don't see a reason to change it. The final two settings are the compression and relaxation settings for our dampening. These are two halves of the same coin. If we didn't dampen our spring, the car would forever bounce around. Just like real dampers on your car, these damper settings will slow the movement of the spring down. The default values of 0.88 are on the high side and will stop the spring motion relatively quickly, but for a race car setup they aren't too bad. You would normally set the compression slightly lower than the relaxation. I'm changing them to 0.5 and 0.8 on our Caterham, but they probably need to be tuned a little bit more. And with that, we complete the first in this series. As you can see, the car drives pretty nicely. There is still loads to do, and I'll revisit this in the near future. I will also place the demo on GitHub later in the week. Thank you for watching, please subscribe and hit that like button if you enjoyed this.